Codeigniter, just like many other frameworks, use a lot of design patterns internally, so let's find out which ones are used in the Codeigniter's its source. So here I have one application, and if we start with the source with the public index.php, we can see a lot of configuration, and we can see also that this app here is made from this bootstrap variable here, and this is basically just a file name which gets the real path back, and this variable basically comes from this bootstrap file, which is basically setting up all the path constants and preparing the application, right? Giving back this very app that we have here, that we see here in the index. So this is this app coming from the require file, this bootstrap PHP file. But besides this configuration above here that's giving us some variables, the most prominent thing is this services Codeigniter. So if we open this services.php, it only extends the base service. So if we go deeper, we can see that this service has a lot of properties, but this is very interesting to me because what they say is that services are simply other classes or libraries that the system uses to do its job, and it is used in place of a dependency injection container primarily due to its simplicity. And also it's better on the long-term maintenance of application, etc, etc. I've never used this approach myself with the services, and having that said, I'm not even an expert on Codeigniter, especially not on version 4. I used it a few years ago, probably 10 years ago, on a version 2, I guess. But I did learn a lot by diving into the source code of the framework. I learned about Active Record, the query builder, and the likes, and all the complex things that I'd never saw before. So I strongly believe that analyzing source code of an application can benefit us a lot. But please correct me if I am saying something wrong about the framework. Anyway, this service here, it behaves like a factory. What it does is by calling some of its method, for example, this Codeigniter, which is a static, we can see that that's a property defined by for the browser as a method at methods, so that the editor, the IDE, can understand what we're trying to do. But this is actually a static method being called, and I found this magic method that's called here, the call static here, which is basically called when we use this static way of calling the parameter, this Codeigniter here. And this to me behaves like a factory design pattern, because this is creating the service. It's checking if the service exists. If it exists, then it's going to execute it, execute the property that's being called. So it acts like a factory that is providing us with the correct and already configured object. They also describe services on the Codeigniter website, and what they basically say here in documentation, that all of the core classes are provided as services, and this file acts as a type of a factory to create new instances of the required class. And they also mention the word factory on this very page here several times on several different places, so it leads to a conclusion that this is a factory actually. However, they do have the factories section on its own and functionality to work with the factories, so the actually factories model. And here, as far as I understood, the factories provide a way to create class instances and access it from anywhere, which is what factory does, sort of, but it looks to me that both services and factories are actually factory design patterns creating you the objects or the objects that we might need, but the services are concerned more with the core classes, while the factories are meant for all other classes or all other models, objects like models and configuration and the likes that we might use in our application. And I also found here in this format method that the factory method actually is used to return the appropriate formatter while they're using the services. So they say that they use it as a factory here as well. So I would assume that both services and factories are actually factory design pattern, one used for internal functionality and the other is more broad and open for us. But again, please correct me if I'm reading this wrong. Regardless, the factory pattern is used to make a creation of complex and correct objects easier, in the simplest form at least. So imagine we need to use multiple shipping objects and each of them has some specific configuration, right? Because they are from all different providers, right? Now we might need to unify them using the adapter to some common interface that we can use in our application so that we can use them interchangeably. But DHL, for example, has a username, password, and also a company name, while the UPS, for example, has a customer key and server and the state, and the FedEx has a completely different configuration for creating the appropriate object. And each time we would like to calculate shipping, we might need to do a big if-else here inside of our controller and possibly in multiple controllers each time we want to calculate shipping and to figure out each of those services what they actually need for the DHL, and then for the UPS, etc., etc. And when we need to add the fourth service, for example, or maybe modify some parameters here, we need to hunt all these down, all this code, configuration code down, and we need to go and change this parameter on pretty much all occurrences of the creation of this very service. And instead of that, we can use the factory pattern, say the shipping factory, for example. And that shipping factory will take the responsibility for creating our objects properly, but also returning us the proper object that we might need to continue our work in our application. Say, for example, based on the product weight, we might decide on some particular shipping service, or if we need some configuration object, we might let the factory decide if we need the configuration based on the correct environment, so that on our local machine we can get one specific config object, and then when we upload the files to the server, we will get the configuration object for that particular environment. Or say for unit testing, we need some different configuration objects or some mocks objects, etc, etc. And by the way, these slides are from my practical PHP design patterns course, which teaches where you can use all these patterns in the real life projects. Link is in the description. Now going back to our application, we saw that there is this Codeigniter service here, and if we open that one, we can see that it's basically a service being initialized, and it has this initialize service method here, and we can see this service exception, for example, that we just talked about in practice. So there is one use of the services to get the initialization for the exception, to initialize the exception in this particular case. But if we go back to our index, we see that this app has this run method, and that run method is in the Codeigniter PHP. So if we look at that one, we see that this is basically the loop, if you will. This is the core, the main entry pointed to the script that gets all the requirements, things, and all the responses, and then pretty much, as they say, makes all of the pieces work together, makes the framework. So this is basically the main code, which is why it's being called here in our index PHP. As they say, it's launching the application. It's actually doing something. So in it, we have some preparation here, but we also see this line that says events trigger, and this is a typical tail sign of the observer pattern or some of its variation. And purpose of this line of code is to give us some, call it a hook, a strategic place in the code where we can insert our custom code. Now, how do we insert our custom code here without actually writing in this file? Is by observing this event here and then reacting to it, having some custom code that will execute at this very point. This allows us to change the default behavior of some app or a framework without us having to change this source code here, because it will be overwritten next time we update the application. I'm now inside the vendor module here, inside the vendor folder, and you cannot change anything there reliably. But we can, using these events, the observer pattern, we can just insert our custom code here as if we are writing it and at this very place here. Or in some other places that are strategically, because Codeigniter has this list of all the events, these event points, where you can just hook up to some events, like this preload, post controller constructor, post system, email, DB query, migrate, etc, etc. So these are the strategic places, and this pre-system that we actually see here in this events trigger, but it also has some events that are happening when it's working with the models. So these before insert, after insert, before and after update, find, etc, etc. So these are some hooks that allows us to change the default behavior of working with database. For example, we can prevent update or prevent insert with some custom validation, for example, or with some custom check or something that we might need to do before inserting some particular object into the database. And this is used, as mentioned, by a lot of applications. For example, this PHP BB forum, it has a list. If you look at this scroll bar here, it has a list of bunch of events that are happening on different strategic places, like this group managed before or after, etc, etc. And even though this is a very huge list of events, it's very important for the forum especially, because that allows us to extend the existing code or core functionality by giving us option to make plugins or to make a custom code that runs at specific points by having that code externally in our plugins. And that way we can just update the source code and still have our custom code execute at the exact same point as long as those events are there, right? So this could be used also if, for example, pre-system, we need to take the entire system down or the entire website, just say that it's under construction while we're doing something. Or we can maybe modify some headers on HTTP requests maybe measure execution time between pre-system and the post-system. That way we can have a benchmark to see what's actually going on with our code. It would be the same as if I would to actually change here and put some say custom code in the source. But the problem is next time I download the application, this entire vendor framework will just be overwritten, this entire folder here. And that is not something we want. We don't want to touch anything in the vendor folder because that's maintained by the packages in my case. And all my custom code that I put here, it will just disappear. So on each update, I would have to manually change all this code back and compare changes and migrate. And that's just, it just sounds like a wrong way to do it. And it is a wrong way to do it. But what we can do is actually to subscribe to this pre-system event. And here inside the config events, we can actually see that there is application events, and we can see already existing one on the pre-system event, which is basically configuring application for testing or not testing or anything else. But if we would to add one more event here, we can have it pre-system or we can have it any other place. Let's see the documentation. We could have it post-controller constructor, for example, just to see. And here we can say exit or stop the application and say maintenance, please visit us later. And then if we were to run this code, we can see that the website will basically stop and it will say that there is a maintenance, please visit us later. Basically, it's executing the code that we are running in our custom code, whether it's being the exit code or returning true or false or preventing some code, etc., etc. So we can do a lot of cool things with these events here. And as mentioned, the observer pattern is very useful for plugins because then plugins can be removed or added dynamically. And you cannot basically predict which plugin will some installation have. Say in PHP PB that I mentioned before the forum. There are a ton of events because we can write a ton of plugins and change default forum behavior in that way using the plugins. We just subscribe to the events that suits us best and then modify the behavior of the app. We add some functionality, we change or even remove existing functionality. Say we need to have several modules and they all need to communicate with each other. If we would to write that code in some controller directly and having this if-else logic and initializing all these classes or in some other class, it would become very messy very soon. Especially we would need to include all possible combination of all removable plugins that could exist. That's just not possible to hard code in any shape or form. For that reason, we introduce one observer layer with bunch of events that each module might either trigger or be interested in and listen. And as long as these events are there, each module will do its thing and we can even remove modules, add new modules, and everything will just work fine. So it's a very useful pattern and pretty much every framework and modular application uses it in some form or another. It's very good to know how it works internally. And again, a shameless plug, in my course we build one observer pattern from scratch, but honestly it's not that difficult, you can just Google it and figure it out on your own. But it's very useful to understand how it works under the hood. And why do you need to know design patterns, you might ask, if you're never going to build a framework and you get them for free? Well, I reach out personally to each of my students and big portion of them get some design pattern question on some job interview, either explaining it or either putting it in the code. Because for every senior position in any serious company, we need to be able to communicate about complex architectural problem and possible solutions and all the drawbacks that they come with that. And design patterns are just tools that we use in our code. Like an electricians would say, in this situation, the best tool for the job is this particular one because of this and that. And every tool is different and solves different problem. So the more tools we know to use, the more problems we can solve, right? But let's continue with the journey. Here in this run method, here at the very end, we have some different display caching and returning responses, handling the response and everything. But we have this page not found exception, and this is one of my favorite design patterns, and that is dependency injection. If we open this display for error, we can see that what it does, it well injects some dependency into this method that this method might use internally. For example, this override might use the get message, or here down it could get the code. And this will not work properly, same as get message here. This will never work properly unless this e variable here is of the page not found exception, because we are expecting that this type of object that matches this interface, that subscribes to this interface, it has all these methods that we expect to use here. So if we would to send a string or an array or anything, it will not work because it depends on it. This method depends on it. And even though this display error is called from this very object, it could be called from any other place, and thus this dependency will be injected here. This object is depending on it, and thus this is the injection of the dependency, right? If we were to look into this handler request method, for example, which accepts the route and the cache and the response, if I open that one, we can see that this actually type of route collection interface is optional. And this route is only used as a parameter here inside this method. It basically does not have to conform to this interface, because again, it's only used as a parameter. So you can say that basically this method does not depend on these routes, and that would be correct because it has this question mark, which means that the null can be provided here, or that this parameter is actually nullable. So in essence, this handler request does not actually depend on this object in any case. So you cannot technically say that this is injecting the dependency, because it's just a parameter that's being forwarded down the path. Same as this cache config, it's only used to be provided further to some other events. As far as this method, this could be a string or whatever, or an empty or an array or something else, but it's not a dependency. To compare that again to 404 method to display 404 errors, this will break if this method does not exist there. So this method actually depends on this one. And while you can argue that this is not a true dependency as to this method not storing this object into its some of its properties, this is still a soft dependency, meaning this dependency is needed in some specific cases and not in all possible cases. A hard dependency can be seen in the actual constructor of the Codeigniter, where we are actually passing this app as the configuration. It's called app because it's a configuration. And this is the eternally object that's being stored internally, and this config is then used on quite a lot of places in the application. And it expects to have this default locale, the app time zone, and all these properties that it needs. But it's basically a true hard dependency, because without any configuration provided, this Codeigniter cannot be run. And one might wonder why it's this configuration not hard-coded here inside the constructor, because we always have the Codeigniter and we always have this configuration, right? Well, the main problem that dependency injection tries to solve is to break the dependency between objects. Sometimes we might bootstrap or configure our application for some local environment, and then for running in the console and not in the browser at all. We could run this index.php from the console here, and it will give us some result, but the app might behave differently. It might strip the HTML. In this case, it's breaking because of the event that I've written. But if we would run it from the console, or if we would to run tests, we might not want all portion of our application to boot at the same time, or to boot at all. So if we would put all those possible configurations here, if I open this app, we can see all these parameters here. If we need to define all that here inside the constructor, it would quickly become a mess, because we would have to have a bunch of if-else's on different parameters. That is why such things are left for the config class itself and being taken out of the Codeigniter class. Then we can just change the behavior of our app by providing different configurations. If we would not to use dependency injection, and each of our classes would have to configure their dependencies like database and logger and shipping instance and configuration, like in our case of Codeigniter, we would soon be in such a mess, because every object would depend on every other object. We would have to connect them all in some way and somehow need to get all the instances on all the possible places. And that's impossible to test, change, or maintain or replace when needed. Instead, we let our controllers provide that dependencies to our object so that the objects remain dependency free, meaning they just get the objects they need already made and configured, and that way we can have objects use other objects, like in our case of configuration, but we still have the option of testing this main object by providing, say, fake sub-objects, fake database, fake logger, or fake shipping service, or fake configuration in our case. We can still replace those objects based on the context, and our code will continue working. Say we might say to provide a different logger on our local machine and a different logger on a server. We don't want to log into files or turn off logging completely on a server. We just want to log on our local machine, because that increases the speed when running live application. And we might want to use one shipping provider for European server and then different to Indian server, etc, etc. And this is one of my favorite design patterns, maybe because it's the first one that I truly understood and say mastered when I was sick and tired of having my code break each time I would need to change something. Using this pattern alone improved my code like a lot. So I highly recommend mastering this one first if you're just starting with design patterns and don't know where to start, because there are a lot of them. Let's find one more just for fun. Let's go back to our services here, these base services. And I already mentioned that this is a factory. And I often get this question from my students, which design pattern is best, or if you can combine them somehow. And the answer is yes, you can combine them, and there is no best pattern because they all solve different problems. And this service that we talked about is a factory pattern, solves the problem of configuring and the complex object chain. However, if we look into this static method filters here, we can see that there is a getSharedTrue parameter, and that indicates that this service might somehow be shared. Now, as they also mention in the documentation, these services have this shared class concept, and they say that using the getSharedToTrue and that all factory methods provide that parameter, we can basically require that only a single instance of a service is created, meaning that we will always get the same instance of some particular class. So one service, say timer for example, it would be created the first time and have that timestamp, but later we might need the very same object that we started, the very same instance, the memory instance, so that we can measure elapsed time on some different places in our application. Say we once start the timer in controller, but then somewhere down in the model we need to have access to the exact same timer object, because if we get a new timer, obviously we cannot measure anything, the times will start from zero again. But by getting the same instance of the same object each time we call it, that object is then used as a singleton. Now technically PHP doesn't have a true singleton because PHP runs by requests and it stops. It's not like Java that has a life cycle completely. And especially this here is not even a partially true singleton because we are free to make another instance when we need it. But it's a method of working with objects as if they were singletons. And the way this works is by storing these created objects here. If we search for this getShared instance here inside of our base service, we can see that they conveniently have this array called, well, instances, where the key is the instance name. And if it's not already set, if it does not already exist, it will be created and it will be stored into this very array, and then it will be returned. Meaning that the first time this one is created, stored inside instances, but all the next time we call our objects that we might need again and again as a single instance, right? This function, this factory, for us will provide this service as a singleton. It will always get the one and only one service that we might need. In our case, we mentioned the timer, for example, but it can be any service that we might need. Say a configuration. We need one and only configuration object throughout our application. We don't want it to change middle of the application. Or say a shopping cart. There is only one shopping cart, regardless of which file we are in. Or even the log service. We want to open the file only first time and not write to some file and not access some file to write into it if it's already opened by some object. We will get some conflicts in the very least, or some other problems of files overwriting each other. So without using singletons, each of our objects would create a separate instance of, say, database. We might have one database created in the home controller, on the home object, then another in the about us, and then another in the contact module. And connection to database is an expensive operation, meaning it takes a lot of resources. And without database being a singleton, we would then use a lot of resources unnecessary connecting to the database multiple times. This is why we can somehow store our database instance to some place, in the Codeigniter's case the service factory, but there are other methods that you can use to store the singleton. Then we can just retrieve this connection only when we need it. And this way we are sure that each and every object gets one and only one instance of database. Or for example logger, which writes to file as we mentioned, and we don't want multiple objects opening the same file due to conflict, and also working with files is a very slow operation. That's why we want to make sure that we only work with one single object, conveniently called singleton. Now watch this video for design patterns inside Laravel and check out my course on applicableprogramming.com. Here is a joke for you.